name is Bharjinit Ashwin Kumar. I am from the data science batch of pre-grade. Today, I am going to present my water potability prediction project where we use machine learning to determine whether a water sample is safe for drinking or not. I will explain each line of code in a clear and structured way so you fully understand the entire workflow from data loading all the way to the model evaluation. Now let's begin. First, we imported the libraries here, which were necessaries. Here you can see we have imported NumPy and Pandas to handle data, Matplotlib and Seaborn to visualize patterns and analyze the data. Now we have imported Scikit libraries to use tools like data splitting, scaling, build models, and evaluate them. The warning filter here is imported to keep the output clean. This setup ensures that everything needed for data science and machine learning is ready. Now, first step is to load data, which is done here. You can see that, right? We have loaded the data using pd.readcsv, which loads the dataset using pandas. When we print the data frame, we can see that there are 3276 rows and 10 columns representing various water quality metrics such as pH, hardness, solids, chloramine, sulfate, conductivity, organic carbon, trihalomethanes, turbidity, and finally potability. Now we check the shape of its, which is 3276 rows and 10 columns, which we already know, and columns are pH, hardness, solids, chloramine, sulfate, conductivity, organic carbon, trihalomethanes, turbidity, potability. We know that the data type here is object. Now we use df.describe to check check minimum, maximum, mean, standard, count, 25% of the values, 50% of the data, 75% of the data, and maximum of it. Now we check whether any row has whether any column has null values or not. To do that, we have used here df.isNull.sum, which tells us that pH has 491 null values, then sulfate has 781 null values, and tri trihalomethanes has 162 null values. Now our job is to clean the data here. To do that, first we will fill these null values with the mean values of that particular rows, which to do that we have used this function here. You can see that, right? It's very simple function which will loop through all columns, and for any column with missing data it will fill those missing values using the columns mean here. You can see that. Now this completes our data set and eliminates all missing values. Now we check again. We can see that there are no missing values in our data and our data is clean now. Now we do our basic EDA on this to check and analyze our data. First we have used boxplot to analyze our data to find whether anything we have outliers or not. Here this boxplot quickly reveals which columns contains outliers. It's an important step because extreme values can weaken the performance of machine learning model. Now to remove outliers we use IQR method. We all know that what it is, right? Here we calculate the interquartile range, then we compute lower and upper bounds. You can see that. Finally, we remove rows that fall outside the lower and upper bounds. Here you can see that we have removed rows which fall outside. By doing that, our total rows are lesser now, which were before around 3200 are now 2666 rows only remaining. Now As you can see, this is the correlation heat map here. Here we plot this to check whether our portability is the only target we need or not. Now here this heat map highlights correlation levels. In our dataset, no feature has with strong correlation with portability here. You can see that, right? Which means water safety is influenced by a combination of many features. Here we have written the correlations with portability of every features. So here there is no strong correlation with any features of portability, right? Now we we do model building here. To do that, first we need to give values of our x and y, where x axis values are every features except the portability, and y is, which is our target, is portability here. Now we split the data to train and test. Here training data will be 80% of our given data, and 20% will be testing data. We all know that as it is and normalized technique which we use mostly everywhere. Here you can see X train, Y train, X test and Y test data which are split among 80 to 20 ratio. If you want to check, you can see that X train has 2132 rows while X test has only 5340 rows. You can scale it now. To do that, we import standard scaler from scikit-learn preprocessing. Scaling is essential here because values like solids and conductivity are much larger than pH or turbidity. Standard scaler puts all features on the same scale, min 0 and standard deviation are 1, which helps models learn more effectively here. So we have scaled our data. Now we select our model. First we have selected logistic regression model, which training accuracy is 62% and test accuracy gives us 64%. Now we have choose another model, decision tree. You can see that, right? Now we evaluate our models. If you want to see, we have put ypred test in decision tree equal to predict of x train, while test is equal to predict of x test, which is similar here as well. Here you can see that we do not need to do that. We can directly put logistic regression into dot fit to x train and y train, where use here we have used scale data of x train. Just like that, we have also used scale data of x train here. Now we evaluate our models. To do that, we have used confusion matrix on our target y train and y train and heat maps as well. You can see that we calculated confusion matrix and plotted them using Seaborn heat map. Next is accuracy, which is 69.6, and a full classification report here which tests precision, recall, F1 score, support, etc. Now our test accuracy here is, as you can see, our test accuracy is 63%, right? That means the model performs much better on the non-potable class. can see that our testing accuracy is 63%, which means the model performs much better on the non-potable class. Potable water means class, that class which we have performed the model or worked the model out on, is harder to identify due to class imbalance and overlapping features distribution. So to summarize this, we can say that we have first first step we imported library, then loaded the dataset. After that we handle missing values, removed outliers, explored correlations, scaled the data, split it into train and trace data, then trained two models, logistic regression and decision tree. After that we evaluated those two models f1 using f1 score, recall, precision of confusion matrix. Now, the decision tree slightly outperformed logistic regression, but since both achieved 63 to 64% accuracy, with technique like balancing the data or using advanced model like random forest or XGBoost, we can further improve our data here. But since I have kept it minimal and basic, so this is a basic level model here. Thanks for listening.